Welcome to the deep dive. If you're trying to stay ahead in enterprise IT, you know the networking landscape. Well, it doesn't just evolve, does it? It seems to go through these huge financial and architectural revolutions every few years. So today, we're here to give you, let's call it, the ultimate shortcut to understanding that shift. We're cutting through the noise. And our sources, they're really tightly focused. We're looking at the core strategic insights from an analysis of the Hpe Hpe2-W12 certification material. That's the one focused on selling HPE Aruba networking solutions.
Exactly. And our goal here isn't memorizing exam answers. It's extraction. We're pulling out the core business strategies, these new rules for how networks are paid for, how they're secured, and how they're operated day to day. Basically, every concept in this material is framed as a competitive necessity, which honestly makes it perfect for this kind of deep dive. We're zeroing in on the differentiators.
Okay. And maybe the most immediate differentiator, surprisingly, isn't purely technical. It's financial, isn't it? For, well, decades, deploying enterprise networking meant this massive, unavoidable, upfront CapEx spend. That model is just fundamentally broken now for companies needing agility. So let's start right there with that revolution. Consumption-based networking.
Right. This is the whole everything as a service era really coming to networking. And the dominant strategic answer to that kind of CapEx lock-in is the HPE GreenLake for networking model.
Okay, let's unpack that phrase as a service because, it can mean a lot of different things. When we talk GreenLake specifically for networking, what's the core function being delivered here?
So its primary function is providing the actual networking capacity, the switches, the access points, the controllers, but delivering it as a pay-per-use service. Think of it like infrastructure on demand, basically. It drastically cuts down that huge upfront capital investment, and it offers that cloud-like scalability and financial flexibility, but for your physical network gear.
Right, that shift from a big one-time buy to an ongoing service. It seems straightforward on the surface. But what's the critical business objective this really supports? It's not just about saving money today, is it?
No, it's much more about agility and, frankly, better forecasting. When an organization moves its network spending from capital expenditure CapEx to operational expenditure or OpEx, they are directly supporting that objective of increasing budget flexibility and scalability. CapEx forces IT to guess its needs maybe 5, even 7 years out. If they guess wrong, well, they either overspend massively or they just hit a really costly wall when they need to scale up fast.
So the move to OpEx makes IT spending elastic. It can actually align with business demand shifts rather than being locked in by these fixed physical assets. That seems crucial in today's economy.
Precisely. You can adjust resources much more easily. A new branch opens or closes. Maybe a merger suddenly doubles your capacity needs. Or network infrastructure costs just scale up or down with the business. Much simpler.
Okay, so we've covered how the network gets paid for. Let's shift gears to the architecture needed to actually make this flexible spending worthwhile. I mean, when the entire network from the data center right out to a user's phone is so decentralized, what's the overarching strategic framework you need to unify it all and secure it?
Yeah, and that brings us neatly to the core strategy, the Aruba Edge Services Platform, usually just called ESP. This is really the unifying architecture for HPE Aruba networking.
ESP. Okay, it's a term we hear constantly. What makes it more than just, a fancy marketing label for the whole product line? What are its defining characteristics, really?
Fundamentally, it's defined by 3 key elements. It's AI-driven, it's cloud-native, and it's built from the ground up with a security-first approach. That's critical. The entire platform is designed to manage and secure that distributed network edge covering wired, wireless, and WAN, all seamlessly. And because it's cloud-native, the management layer is completely separate from the hardware lifecycle.
So you get continuous feature updates and simplified operations across all those different ways people connect.
Exactly, without ripping and replacing hardware constantly.
Now, this is where those architectural choices have huge security implications, right? If the network is distributed, security can't just rely on the old perimeter defenses anymore. It has to be, baked in right at the point of access. So let's talk about the essential component for implementing Zero Trust today. What is that?
Right. Implementing true Zero Trust, it really demands granular control at every single access point. And the key component for enabling this is the Aruba ClearPass Policy Manager.
ClearPass, so it's the policy engine. But what's the strategic function it performs that makes it so indispensable in a modern Zero Trust world?
Well, think of it as the ultimate access control bouncer, if you will. ClearPass doesn't just check a username and password. It authenticates the user and the specific device they're using. Then it checks their security, posture like, is the laptop patched? Is its disk encrypted? Does it meet our compliance rules? And only then does it enforce very precise access policies before granting any connectivity. Nothing gets trusted by default.
And this unification you mentioned, that must lead directly to a pretty massive competitive differentiator, right? Eliminating those policy silos. Historically, managing wired policies and wireless policies, that meant separate systems, didn't it? Sounds like an operational nightmare.
Oh, it absolutely was a huge source of complexity and, frankly, security gaps, too. ClearPass fundamentally changes the game there by delivering unified policy management across the entire access layer. So whether it's a guest connecting via Wi-Fi or the CEO plugging into an Ethernet port in the boardroom, they hit the exact same policy framework, the same rules. This centralization, it just dramatically simplifies management, eliminates those dangerous policy inconsistencies, and really cuts down the operational burden that, organizations using dual systems from legacy vendors constantly struggle with.
Okay, that makes the access edge sound much simpler and more secure. But let's pivot to the data center. Traffic volumes there are immense. Security is non-negotiable, but applying policies can't kill wire rate performance. How do you apply that same distributed security idea inside the data center without introducing crippling latency?
This is honestly one of the most exciting strategic shifts we're seeing right now.
Uh-huh.
And it's really embodied in the Aruba CX10000 switch. What's unique in the data center market is that the CX10000 integrates a DPU, a data processing unit, directly into the switch hardware itself.
A DPU inside the switch. That feels like a significant move. We're used to switches just forwarding packets. Now we're putting serious processing power right there in the switch fabric. What strategic function does that DPU perform?
It enables distributed, wire rate security, and segmentation right at the switch level. And the strategic implication here is huge. Instead of having to hairpin all that traffic, especially the east-west traffic flowing between servers out to some massive centralized security appliance and back, the CX10000 enforces high-performance firewall policies locally right on the switch.
Wow, okay.
Yeah, this slashes latency, it drastically simplifies the data center network design, and it provides genuinely pervasive security without choking application speed. It pushes security enforcement much closer to the actual workloads.
All right, moving from security hardware then to operational intelligence. Let's look at how AI is showing up in just the day-to-day management. We've established the network is intelligent, but what does that actually look like when the IT team is trying to avoid that constant reactive firefighting?
Yeah, the goal is to shift entirely proactive, and that's powered by Aruba Central AI Ops. The core function of AIOps isn't just monitoring, it's about detecting network anomalies and then providing prescriptive insights for resolution.
So it's not just like sounding an alarm when the whole system crashes. It's catching those subtle early signs of things starting to degrade and actually recommending a fix before users even notice. How does that translate into real-world time savings for IT?
Oh, it's critical. Traditional monitoring just generates way too much noise, too many alerts. AIOps uses machine learning to sift through massive data sets, quickly pinpointing the likely root cause. And crucially, it offers actionable recommendations. Things like, hey, adjust the power on access point 4B. That should resolve the channel congestion. This dramatically speeds up troubleshooting. It moves IT away from spending hours just trying to correlate isolated alerts into figuring out the actual problem.
Okay, that addresses the infrastructure side. But what about those times when IT knows the infrastructure seems fine, but users are still complaining about intermittent application performance? You know that classic, the connection is great when you check, but it was awful 5 minutes ago. How do we proactively monitor the actual user experience?
Ah, yes, the ghosts in the machine. To combat those really elusive intermittent application issues, the solution you need is Aruba User Experience Insight, UXI sensors.
The robot users, we talked about these before.
Exactly. These are small physical or virtual devices you deploy strategically, where users actually think conference rooms, remote offices, maybe high-traffic campus areas. They essentially simulate real user behavior 24/7. They're constantly connecting to the network, logging into key applications like Zoom or Salesforce, validating DNS, measuring application response times. Basically, they proactively test and validate the end-user experience from the client's point of view.
Right, and the genius there is that the UXI sensors can often identify and help resolve issues before real users are even impacted, or at least before they complain. IT can look at the sensor data and see, aha, VoIP quality tanked at 9:06:05 a.m., even if the first help desk ticket doesn't come in until 9:03.
Precisely. It helps turn IT from being reactive ticket closers into more proactive service managers. They're maintaining network health from the outside in, from the user perspective.
Okay, That brings us to our final set of strategic insights, really focusing on flexibility and overall market value. When you're competing against, let's say, legacy vendors who try to lock customers into proprietary systems, what's the counter strategy for ensuring adaptability?
Well, the key strategy against competitors who rely on those proprietary, often inflexible architectures is really to highlight Aruba's open, API-driven platform for integration and flexibility. Vendor lock-in is still a massive concern for IT leaders, and rightly so. By maintaining an open, accessible platform with robust APIs, organizations ensure interoperability. They can integrate best-of-breed third-party tools, maybe specialized security platforms, or custom automation scripts without being hamstrung by a single vendor's roadmap.
Guarantees that long-term adaptability. Okay, and finally, lots of organizations are still heavily reliant on legacy WAN infrastructure, typically those expensive MPLS circuits. What's the core financial and performance argument for migrating to modern SD-WAN, specifically looking at Aruba Edge Connect?
Yeah, this ties directly back to our very first point about CapEx versus OpEx and overall cost. The key value proposition for moving from legacy MPLS to Aruba Edge Connect SD-WAN really centers on two things: lower total cost of ownership,
Right.
TCO, and significantly improved application performance.
Help us quantify that TCO reduction a bit. Where do the savings actually come from? Is it just cheaper circuits?
It's largely about optimization, actually. Edge Connect intelligently optimizes traffic over much cheaper, readily available broadband links like business internet or even 5G. This lets businesses strategically decommission or reduce their reliance on those historically expensive dedicated MPLS circuits. So you often get higher overall throughput, you get better, more direct paths for cloud and SaaS applications, and yes, significantly lower overall circuit costs. It turns what was often a financial sinkhole into a much more strategic and efficient area of spending.
Thanks for joining us. We hope you feel significantly more well-informed about where things are heading.